I want to give a big hand to our sponsors because they are awesome. To put on an event like this, and all the people who have been helping throughout this, a big hand for them as well. So Benson's right. My name is Ryan Doan, and you're in Yo Mama's Got JavaScript Design Patterns. And I can't pronounce it or say it, and so every time I slaughter it, but hey, it's fun, right? I want to start out talking a little bit about myself because I'm up here so I can. This is my shirt I was wearing this morning. My wife said it is too bright and I cannot wear it to this conference, but I'm going to show you anyway. My daughter does, I've got 3 kids who do soccer just in the recreational leagues, and I'm coaching this year, and I ended up getting the hot pink, which I think is just freaking awesome. I mean, I was upset at first, but I then decided, I'll just live with it. It's good, right? So it's me. Oh, thank you. Thank you very much. So this will come in a little bit later in part of my talk. I'm a senior software engineer. I've worked at a number of companies, building a product called MyCanvas and at Ancestry.com. I've been doing professional development for over 10 years now. I work at a startup called Client Success. And my favorite part is I'm a father of 4. I love my kids, ages 9 down to 2 years old. I want to shout out to my company, Client Success. We're a small startup, but we're making waves in client retention. And if we're always looking for sharp developers, so if you're looking for a job, feel free to talk with me afterwards, and we'll talk with you. But to the point, today we're talking about design patterns. Who out here is familiar with design patterns? And what level of familiarity? Like very beginner, raise your hand. And that's cool, awesome. We got a few. Super advanced, done a ton of work using design patterns. Okay, middle of the road. Looks like most everyone's kind of middle of the road and beginner. That's great. This talk is primarily focused on an introduction. Design patterns are a funny thing. I've struggled with design patterns most of my career. I have 4 books at home on the subject that I've gone through and read. But it's always been hard for me to kind of coalesce them into something practical that I can use day to day. And so I decided I'd give a talk on the subject since, people who aren't experts should give talks to become experts. And it's helped a ton. Design patterns are actually a whole lot clearer to me than they ever have been. So let's start with a brief history here of design patterns. So the term patterns was coined by an Austrian-born architect named Christopher Alexander. And he was an American architect born in Austria, not Australia. And he wrote a book called A Pattern Language that talked about reusable patterns in architecture, in real architecture, not digital architecture. So analog, there we go, analog architecture. And in this book, he talked about patterns of building buildings and also building cities, how to lay out roads so they work well, how to structure buildings so they work well. And kind of as I see it, the purpose of design patterns is to help us communicate, save time, and also to abstract ideas so that we can think in broader scope. The human mind can only think of a small set of things at a time, but if we can compartmentalize things and put them into smaller pieces, then we can put a bunch of those pieces together in our minds and think about something that's a big problem more concretely using abstract ideas. Kind of weird to say it, but that's kind of how I see design patterns. So a little bit about communication. So here are a couple of design patterns for architecture, just for how to cover a building. There's many, many different ways of covering a building. And this is just your typical house or small structure, some ways of doing that. All of these have different names, and as you can see here, so if I wanted to build a roof, and I went to an architect and said something like, I want a roof with a top line that follows the full length of the house. The top line should be in the center with equal length sides, each pitched at the same angle towards the center. the architect would try and decipher what I'm talking about, and then he might come back and say, oh, you want a gable roof. This is what I was trying to describe with that. If you have a clear picture of what a gable roof is, you can communicate a whole lot clearer and more efficiently. Secondly, patterns save us time. So say people writing code or building buildings might say, oh, but I want to design my own roof. I want to build something fantastic. Something like this. Well, how long do you think it took the architect to design and build this?
I don't think an architect designed that.
I love that. That's awesome. It looks like just kind of a fandangled approach. Now, there might be real purpose in taking time to build a roof. A gabled roof would not accomplish this architect's purpose. I think this architect's purpose might have been self-aggrandizement, or it might have been just to build something that was unique so that it could be inspiring to other people. So sometimes there are reasons to not follow a pattern, but a pattern will still help you get there. So the next thing is the patterns help us abstract the ideas. Remember when we looked at this before, there was a shed roof in that bottom corner. Even though this pattern is super simple, it is a great starting place for different things. So what if an architect came to you and said, what if we start with 5 or 6 shed roofs, put them on varying planes, warp them a little to make it more interesting? Well, he's trying to describe something like this. So even though he's not directly using a pattern in this, he can use patterns to describe what he's trying to accomplish. And other architects will understand what he's trying to accomplish a little bit better. Let's look at a little bit bigger structure here. This is Miller Park in Milwaukee. And it features this really cool fan roof that closes. It only takes 10 minutes to close this whole roof and enclose the entire baseball stadium. And this is what it looks like from the inside. That's horrible. Let me see if I can turn off one of these. Don't go to sleep on me, right? Is that better?
Yeah. Much better.
Yay! All right, so now you can actually see the beams and trusses up here holding up this roof. Well, again, this would take a long time for an architect to design and build, but he can start with another really simple pattern, right? The gambrel roof. All right, so what? How does this apply to development? Let's get back to the devs. So, software patterns. How many of you have heard of the Gang of Four? Oh, not as many as I thought. All right, so we'll get to that in just a second. Justin Meyer said this: the secret of building large apps is never build large apps. Break your applications into small pieces, then assemble those testable bite-sized pieces into your big application. So if you look back at this structure, there are multiple gambrel roofs. There's one right there, 3 there, 3 over there, and they all swing into the middle. So they've deconstructed the problem into an easier problem to solve. So the Gang of Four is a group of 4 people who wrote a book called Design Patterns. And this was the first big work on the software design patterns and applying this to software. And there are 23 patterns in there in 3 groups. And these 4 people became known as the Gang of Four. So if you ever see Gang of Four or GOF, capital G's, lowercase o, capital F, that's these guys who wrote this book. They wrote this seminal work on design patterns that's still in use today. So here is a huge list of all those patterns. We're actually not going to dig into all of those right now. These ones here that I've bolded are more interesting in JavaScript, maybe less in other languages. But on top of that, there are other patterns for architecture and other parts of your application. So you might be saying after looking at this, I thought you said this was going to be Easy. Simple. I thought this was an intro to design patterns course. You did think that, right? I mean, it's in the description. Well, that's okay. Today we're actually just focusing on 3 of these: module, facade, and mediator. So let's get into some code. JavaScript object patterns, starting with the module pattern. So JavaScript doesn't have, or didn't have, any sort of concept of modules when it came out the gate. ES6, yeah, you've got a module pattern in ES6, but not everyone can use that yet. You also have AMD and CommonJS and other module patterns that can be used. So the module pattern, as defined in the Gang of 4 books, says there's a problem. The problem is that JavaScript doesn't have built-in modules yet, or when applying it to JavaScript, and that private vars and methods don't exist in simple JavaScript constructs. So let's look at an example of how we can make that exist. Here's some JavaScript for looking at a module, or for creating a module. At the very top here, we have this immediately invoked function that creates a closure around your JavaScript. That means everything, you can bring in objects from outside of this, but this is self-contained. And then at the top here, you can see we have some private variables and methods. And then we return out of this immediate function, we return public variables and methods. So we might have a private method up here that gets called in our public function, or a private var that's accessible that we either make accessible here, right, it's not in this example, or we just call it in our public method. And that's how we can consolidate things and make a module that can be a reusable component. There's a slight variation on the module pattern, which is called the revealing module pattern. And what we do is we take this lower portion of code and we move it up. So all I did is take that out of this return and moved it up right here. And you can see I'm returning this myPublic function that just references the function right there. And that allows us to really have a better view of what is public and what is not. It also allows us to access this public function from some of our methods internally if we want to. But the whole purpose of the module pattern is to help us keep things clean, keep the structure of our JavaScript clean, and also to not pollute the global namespace. So here's some of the advantages of the module pattern. Helps us separate and encapsulate our JavaScript. It increases readability once you get used to it. It's really weird the first time you see it. I should ask, how many people have used some pattern similar to this in your code? Awesome. It's become a pretty standard approach. Adi Osmani wrote about JavaScript design patterns, and this is one that he highly recommends and has been adopted widely. So there is a disadvantage, which is that private methods can't be patched or extended. We don't often think about patching and extending modules in JavaScript, but in other languages that's much more common. What that means is anything in this top area, that private method, if I make a new module that extends this module, I can't change the implementation of that. You have to aggregate instead, so make another function that calls that. It can't directly overwrite it. And here are some of those examples I was referring to earlier. AMD, CommonJS, ES6, object literal pattern. OK, module pattern, good? Any questions on the module pattern? Am I going too slow? Going too fast? Good, perfect. Let's push on. So we're going to go over to the facade pattern now. Who's heard of the facade pattern before? Heard of it? Have you implemented it anywhere? Anyone know where this is used that you might use every day? Sorry, session? Session, I can't quite hear you.
Yeah, session facade.
Session facade? I'm not familiar with that one directly. But it very well could be. You'll have to decide as we go through it. So I'll point one out at the end of this where you use this probably every day and maybe without knowing it. So when we put up a facade, we present an outward appearance to the world, and we conceal a very different reality. This is used all the time in browsers. Think of different browser implementations. So here's an example of doing an event listener. One of these is, I don't know which one, I can't remember now. One of these is IE7, one of these is IE8, and one of these is real browsers, right? So in a facade pattern, there are multiple implementations or multiple possible implementations. And in JavaScript, where we have multiple runtimes, meaning there's a browser, many different browsers, and our code has to live and work in all those different browsers, the facade pattern is super, super helpful because we can consolidate all of these different implementations into a single method. So here you can see we have these three different implementations, and we consolidate it to add event. Now all we have to do is call add event, and that's used everywhere. So some libraries, here's some of the problems that Facade helps us solve, is that libraries or browsers or APIs have different implementations, and so coding directly to those implementations locks you in or creates a whole lot of extra code. So here's an example where you might be using it every day. Who uses jQuery?
So I was going to say, now that you showed me, I was going, jQuery is a one gigantic facade for a ton of functionality.
Exactly. jQuery, the reason why it's so popular is because this is what it does all day long. It abstracts away all the hard things that browsers have implemented so many different ways and makes it easier to use. So here's adding an event listener so that for the bind ready, for document ready. So just document load is implemented all these different ways in browsers. So again, the 4 different implementations and putting it to this one function, single method call. And even that has a facade on top of it, which is the document ready or just the $paren, or I can't remember. I always have to look that shorthand up. Pull it from another file that I've used. Another example is like the jQuery Ajax. You'll see Angular directives wrapping third-party code. Who's worked with D3 before? We got a couple. So D3 has some really interesting approaches to working with SVG. D3 is basically working with SVG the same way jQuery works with DOM. And anyway, so if you want to consume that, you might write, if you're an Angular user, you might write an Angular directive that wraps all the weird functionality that D3 has, and then you can reuse that elsewhere in your application. So some of the advantages of Facade is it simplifies interfaces, reduces repeated code, and increases readability. Once again, these are my favorite parts. If you don't have a Facade, you're going to be rewriting that check for what type of Ajax this browser uses all over in your application. So it just helps us keep it more dry. Don't repeat yourself. And of course, there's a small performance hit because you're checking to see what implementations exist. All right, questions on Facade? Okay, let's go to the Mediator pattern. So a Mediator sits between, and we're going to pull all these together in a minute to build a full application. But this one, a Mediator sits between various components and acts as a single place, and the messaging routing changes can be made. That's a little esoteric for me. Think of it as an air traffic controller. So you've got the air traffic control tower that sits there, and there may be 50 planes on the runway and 50 planes in the air all circling. Now imagine for a minute, just for a minute, if you were to have all these planes talking to each other back and forth without some central point. You'd have 100 different planes trying to communicate, saying, okay, who's up, who's next for landing, who's next for coming on this approach. Does this airport use a circular approach, or how do I come in for this runway? And there would be a lot of cross-chatter or cross-talk, and we'd have plane crashes all the time. So enter the air traffic control tower, they take the messages that come from all these different planes, from the pilots, co-pilots who talk to them, and they give messages back. So an airplane comes into the vicinity of the airport, the control tower says, aircraft 107, you're third in line for runway 3, and I don't know. I'm trying to make things up. I can't talk like an air traffic controller guy. But I want to give one other example back to this shirt that I think is so awesome. In fact, let's get a little light. Who here has kids? That's a lot of us. How many play soccer? No? So who's seen a group of young kids who are just starting out playing soccer? Right? They're all huddled around the ball. You got 6 kids all huddling around the one ball in the middle. Some kid kicks it out of the huddle, and they all chase. This whole pack chases that ball just around the field, back and forth. It's awesome. So much fun. So the coach's job, my job as a coach, is I just sit there the whole time saying, spread out, spread out, spread out. And that's, you can be a coach if you can say spread out. But I act, in a way, as a coach, you act as, of a small team like that, you act as the air traffic controller saying, okay, you two, you're on defense, you two, you're strikers, and you two are midfield. And you try and help the kids understand that. And then as the game plays, you help facilitate back and forth what's going on. So let's take this example of air traffic control, or of mediator pattern, and apply it to building an email client. Who's built an email client out here? Got one in back. Hi, Scott. I hadn't seen you before.
Right now, actually, so.
Nice. I work with Scott. And yes, you doing that this weekend?
Yes, I'm doing that this weekend.
You need to use the mediator pattern.
I will.
All right. So you might be thinking, well, writing an email client, that's easy. That's not that bad. All I do is just make this email client component and have it. I could have 3 different components, in fact, have them communicate with each other. So I could have this viewing pane for emails, and then a list of where the emails are, and then email boxes. It could be inbox or spam or all, whatever it is you want to show there. That's really easy. And yeah, splitting it up like that using the module pattern, that's helpful. But what happens when you get an email? Let's start walking through the communication between these 3 different pieces. So let's say you get an email into your inbox. And so the inbox is going to say, hey, email list, I have a new email. It hasn't been viewed yet. And then the email list says, oh, that's at the top of my list. Viewing pane, let's show that. Or maybe the user clicks on it and shows it. And the viewing pane says, oh, hey, we've looked at this already, so go tell the email list, all right, I viewed it. I viewed the email. You can unhighlight or whatever you want. Email list says, oh, great, this has been viewed already. You can mark that as now there's no viewed emails. But what happens when we add other things? So say we have stars, and we need to communicate about the different starred or unstarred, I don't know what you call it. Starification. I like it. So now that's going to add some complexity. Maybe we have labels that go back and forth, and you got to have labels showing on some areas and not. When you add a label over here, it needs to show up on the pane over there. So now this guy is communicating directly to this guy, and then let's add some dates. And let's add some maybe unlicensed Disney fan art. And suddenly the communication of this gets a whole lot more complex. Each of these components is having to communicate with the other one. We only have 3 components here. If we go back to our air traffic control analogy, even if you just have 3 airplanes, crosstalk is going to be a problem. And so enter the email mediator. So I think you can figure out where it's going from here. The email mediator sits in the middle and communicates back and forth to these. The viewing pane, if something gets viewed, it just says, hey, email mediator, somebody viewed this. So yeah, somebody viewed it. That's it. That's all it says. And then the email list says, hey, when somebody views emails, let me know about that. Or boxes, when somebody views emails, let me know about that. And then they can update. So that's all that the mediator pattern is. It's just a simple go-between between different classes. So the problem, objects often need a way of communicating with each other, and crosstalk can be a problem. So Mediator promotes loose coupling and improves code maintenance. So one of the issues, question right here.
So it seems like at its core, and there's a ton of other functionality built into it, but at its core, it seems like Angular is one like gigantic, big beefed up mediator.
That's an interesting observation. So the question was, so at its core, it seems like Angular is a big beefed up mediator. And I think so in a lot of ways. It has the...
I mean, there's a ton of other stuff, but it mediates between...
Sorry?
They call it dependency injection, but I think there's shared.
So it has both concepts,
Dependency.
dependency injection as well.
But what I'm talking about is the mediation between something changes, I change something in the DOM and it gets changed on my back end. But also if it's elsewhere in the DOM, it also gets changed there. Where these two elements never have to communicate with each other, but they're both being mediated by the Angular back end.
Yeah, that's totally right. The example was you have a couple of pieces on the DOM and you've got an Angular backend, or even further back, you've got a backend as a service. For Scott, he gave a talk on that yesterday. Anyway, they all need to be in sync with each other, and yeah, it mediates that. Now, you can avoid using the mediator pattern in Angular, and I don't recommend it. I've done that especially when I was newer in Angular, but also when I've been just trying to hustle and get through things, and it can bite you big time. So a couple of implementations or examples would be like this email client we saw, or maybe a scoreboard and a player within a game. So if you're building a game, you have the scoreboard that wants to know about when a player dies or when they jump on the little mushroom things or whatever it is. All right, any questions?
You mentioned the mediator when the problem is a single point of failure. Why is single point of failure a bad thing?
Why is it a bad thing in this situation? So the question is, why is single point of failure a bad thing? Mediator, that's one of the issues that it has. So the problem is if you make if you have a coding error in your mediator, or if something blows up in your mediator, then all of the components stop talking to each other.
Yeah, common pattern there, just any Windows event-driven programming with a message pump and stuff like that. All it takes to break your application is to have a blocking call that lasts 5 seconds of your whole system.
There you go. So the comment was for recording. In many different architectures, all it takes is to have a blocking call, and that stops your whole mediator. And an event loop in that case, he says. And yep, I totally agree. So does that answer the question? Sure. Any other questions?
I was just going to say, when you're talking about Angular, I think the digest loop in Angular does a lot of the follow the mediator pattern. And it just has that exact same problem where if you throw a bunch of stuff on the root scope, or if you have a ton of launches or filters or whatever, it could slow down your entire application.
Yeah.
Not just the one thing that you're looking at.
So the comment was that when there's, in Angular, the digest loop in particular is a mediator, and when you have a lot of things on the digest loop, it slows down the entire application. Awesome. Anything else? Cool. Well, let's put this all together. I mean, these are really simple things, but the cool thing about these 3 simple patterns is that with these, you can build large-scale applications. So let's put it all together. So let's say your boss comes to you. Your designer has been working feverishly for 2 months, and he comes up with this. And he says, hey, I want you to build this. And you look at it and you say, holy cow. Tell me about it. And your boss says, well, it's not that bad. We've got this email client right here. We've got a list of contacts from that email over here. We want those contacts up here so that when they make some comment, it shows, and we want it all to be real-time and interactive. So when an email comes in, it just shows up here, and if there's new contact in the email, they show up over here, and the bubble shows up, and it just animates in. We want it to be awesome. Right? Okay, who's had that happen, right? Maybe not this design, this mock. This is very close to the application I work on, actually. And the boss says, it's not going to be that hard, right? And you say, sure. Well, it's not. So let's take this and let's split it up. So adios money again. If working on a significantly large JavaScript application, remember to dedicate sufficient time to planning the underlying architecture that makes the most sense. Because if you have something like this, and you just start communicating between all these pieces, you're going to have, I tried to color code here, so red talks to red, and then orange to orange. You're going to have all these intercommunicating things. Not only that, but we already saw here that we've already got intercommunication right within this. So you're going to have a lot of bugs if you don't take the time to architect this a little bit. But really, it's not a problem. You got this. It's just like these. We're going to take some patterns and apply them. So I'm going to remove some color here, simplify a little bit, and let's start with just one application, or one part of this page. Well, looking at this is that exact email client that we just built. Remember, we've got the Mediator pattern around this. And what we can do is we can take that and call it an email module. So again, we're using the module pattern to compartmentalize this. And we can take that module and drop it in the page, and then we're going to module all the things. Right? We're going to make a timeline module, maybe a header module, a people module, and some other module. I don't know what it is. Maybe this is a golf module because your boss likes to golf, so you just throw it in there. And so we have all these modules on the page. Well, that's awesome because now they're compartmentalized, and if I need to work on this customer list, I can dive into that code and work on just that customer list. And what else is awesome is now we can use the facade pattern to have these communicate with each other, or to start the communication. So when we start thinking about these modularized things, we need to figure out how they're going to communicate with the other pieces of the application. So we could have, on the email module, we could say there's a method here that says get active box and get active email. But those could get messy really quick because of the same thing we just talked about with the cross communication. So with Facade, we want to forget about the internal details of how this works, and maybe all we do is just have a get email count. Because elsewhere in the application, all that the rest of the application cares about is email count. No, we haven't seen anywhere else in the application maybe that they care about anything else. So that's great. So let's add a couple of other methods here. Maybe get all the people, and there would be another add person over here or something like that. And so we can create these facades for each of these modules. And then to facilitate communication, we add in a mediator. And that mediator helps us communicate between these different components. So that there we have a full application that can talk to each other. Each of these can be worked on individually. If we need to replace one of these modules, great, we can replace it without affecting any of the other code. And there you go, a large-scale JavaScript application with just 3 design patterns. So I think Napoleon said, software design patterns will help us rule the world. Only left hand, right? I don't have the shirt for it. This one doesn't help either. But wrapping up. So just as architectural roof patterns can help us communicate something as complex and weird as this, or even this, that's a shed roof, software design patterns can help us build something as complex as this. Thanks. Any questions? No questions?
Sorry, I missed part of this.
Oh, you're fine.
Making this LED thing. So facade pattern kind of works as like an API for your modules, right?
That's exactly right. So the question was, so the facade pattern acts as kind of an API for your modules, and that is exactly right. Great question. Any others?
Those 4 books you have at home, which one would you recommend someone read first?
So here's some of the resources. And I would recommend the awesomeness one if you're focusing on JavaScript. You notice I didn't even put the Gang of 4 book up here. It is very hard to decipher. It's a computer science book. Very dense. Thank you. And I've got these slides available, and I'll send out the link. Question? Elegant JavaScript? Yes, I have.
Do you like that one?
I do. I like that one. I'm trying to remember specifically.
That too is like a supplement to design patterns thinking because it shows you how to. It has more practical kind of applications than JavaScript or some of those things.
I mean, eloquent.
Elegant.
Sorry, eloquent JavaScript.
Oh, there are 2 different ones. There's eloquent and elegant.
Oh, I don't know which one I mean. Elegance, I think, is the one that doesn't come to mind.
I can't remember either.
The eloquent JavaScript books online free.
Yeah, and so is this one. This one is online for free.
Really?
Is there not an elegant one?
Mike is
I totally must be mixing it
Mike
up.
is the one who recommended the eloquent one to me, so he knows.
What is the name of that one?
Yeah, I mean, I'm not, Google can't find it anyway.
Well, I know better than Google, of course. No, I totally must be getting the name of the one wrong. There was another one that's awesome. But yeah, awesomeness, this one, I like that one best, and it's free. So, any other questions? Awesome. Thank you, guys. Thank you all very much.